So, welcome to the last exercise where we'll create an enclosure for your microbit and a sensor bit shield. So, when we're doing this, we'll import some CAD drawings of the boards themselves. These are easily available many places on the internet. So, I've uploaded two files on the Padlet, one called SensorBit and one called Microbit. So I'll start by uploading them. I've already downloaded them into my computer. So hit upload, select what files you want to upload, and in this case the Microbit F3D and the SensorBit F3D. I hit open and upload, and now the files will be uploaded into the folder I created for this purpose. So it takes just a little while, and now they are both present. Next up, I'll save the empty document, and this is because I can't actually insert these into a document that has not been saved. So I'll simply save an empty document, and let's call this Microbit Enclosure. So having done that, it'll save it in the folder, and now I've got the two other parts present. So first off, I'll insert the sensor bit into my design. So I right click and select Insert into Current Design. And it will insert it, and I have the ability to move it around, either inserting values or just using these handles. I'll not do that for the first part, namely the sensor bit. I'll just hit OK, and now it's inserted into my my design. So next up, we'll import the microbit into the design. Right-click microbit, insert into current design, and just as before, it'll insert it into the very center, which is actually not the place I want this design. So I'll just move it a little bit out of the way. You have various controls for moving. I can move in plane. I can move both in this and this direction and once in all three planes, and I can rotate around in all three planes. But in this instance, I'll just move it a little bit out of the way here. And if you notice, the orientation is actually reversed as to what I want. So I want to move around. I can rotate in this direction, in that direction, or in the planar direction, but in this case I want to move it 180 degrees so I get access to the LEDs and the push buttons on top. So hit OK. Next up, we'll need to create a joint between this one and this one. Until now we've created moving joints, but hitting joint, it'll default to a rigid joint, which is what I want. And the thing we haven't really touched upon as of yet is that when you actually select a given surface, it has various points I can select as the origin, including one at the very center of the face. So I hit that one. Next up, I'll need to find the receptacle on the sensor bit board. And if I review it just right from the very end and zoom in a bit, I can access this surface. And again, there's a lot of points, but again, you might notice there's a center point right there. So if I select that one, the point I just selected previously and this point will be mated. And that's a perfect orientation of the board. So when you insert the physical board into the sensor bit, this is exactly what you'll get. So now we are ready to begin to design a case around these two components. Hit save just to be sure. So we've got it saved. So we'll create a new component called bottom. And let's draw this one, this plane. So I'll want a case that's big enough to contain both the sensor bit board with access to all the pins here and the microbit board itself. So basically I'll just draw a rectangle surrounding these with a bit of space. If I just choose the rectangle and hit L and create a construction line going through the center, I can align this so that it'll be in the origin. So I'll just hit coincident, take this line and say it has to touch upon that one, and then my design is actually centered. So in this case I'll just do the approximate dimensions, and then I'll do the D and select some dimension conforming to whatever I've selected, so 62, and in this case about 70. Yeah, 70 should be fine. So now I've got a design which seems to be centered quite nicely. I would like it to be fully locked. You can notice the blue lines, and that's because I haven't actually set anything in this direction. So I've locked it in this direction because I had the center line going through the origin. So in this case I'll just hit the origin and the top and say, well, I want there to be 23 millimeters between these two, and now it's all black, indicating that I've locked everything into place. So that's a good starting point. Now I have a plane. So I'll hit finish, and it is a good orientation. Yep. So I'll hit E and just extrude this to, let's say, yeah, sure, -3 is fine. Because that's actually a little bit of a problem. If we just go to the top level design and view the sensor bit board, I'll just hide the bottom for a moment, you'll notice that there are all these dots at the very bottom. This is actually correct. When you look at your sensor bit on the bottom, there are a lot of holes, sort of a lot of pins. These header pins go through the board and a little bit into the bottom. So we'll need to create space for these. So we need a cutout in the bottom corresponding to this area. So we'll select the bottom again, and I will choose the top surface of the bottom. And then we actually just need to cut out this area corresponding to the various pins. So I will create a rectangle approximately big enough, and just hit dimension and say this one should be 16, and this one should be 42, should be fine. Next up, I would like to center it. So once more, I can just create a line going from the origin to here, and we'll make this a construction line to the center of the rectangle I just drew. And this one, if we set this one to vertical, it'll move it into place and be centered. You might notice the pins are not perfectly centered. I honestly think this might be my fault. I drew this board manually just today, and I actually think these header pins are centered. So I think this should be a good cutout. So I'll hit finish, and then we just need to extrude a little hole into the top of the bottom. So go into the bottom, hit extrude, and get this surface, and just draw it down a little bit. So these are about -1.5, should be fine. So again, if we look from the front, you should have sufficient space that these pins will not touch the bottom of the enclosure. So I'm happy with that, that's good. Next up, we'll need some studs to hold these in place. So once more, I'll hit the top surface, choose draw. Now the good part about having these tools available is that I can easily project stuff. So hit P, choose the construction and say, actually I would like these two circles to be available as geometry. And then they actually appear. The reason I drew them as construction is that, of course, I could have chosen them and extruded them, but as I mentioned in a previous video, when you extrude stuff or print stuff, it'll be ish the dimension you choose. So if you do these circles exactly corresponding to the holes in the SensorBit board, you'll run into trouble. So we need some sort of spacing to allow for tolerances in the printing. So I'll hit C and deselect the line type. Zoom in a bit on this area. And now I've got the two centers, so I'll just hit that one and draw a circle, and hit that one and draw a circle. Hit D, and now you can choose the two circles and say how far should there be between these. Typically when I 3D print stuff, I'll select 0.25 or 0.3 to ensure that there's sufficient spacing. So likewise, select these two circles. And in this case, I'll just hit this dimension to have the same tolerance between them. So next up, we would mirror these two circles to the other side. So I'll just hit L and create a construction line from the origin down to the bottom somewhere. Doesn't really matter, just a vertical line. And then I'll do the create mirror, and I'll get the two inner circles mirrored about this mirror line. So now I've got all four circles, which is what I wanted, so I hit finish, and then I can E for extrude. And now this board is actually in the way, so there are two ways of going about this. Either I could hide the board just by clicking on the sensor bit, and then I can easily select all four. Or I can actually just hold down the left mouse button and I get an access to what's present at that specific location, including a profile, which is actually the one I want. And the last profile. So next up, we'll just go to the right and say these ones should be extruded up through the board. So something about 2 millimeters should be fine. So if I hit OK, and then you can see we've got this board locked in place. So promising start. Next up, we will be going round, seeing that the Microbit board is actually hovering above the bottom, so that's not too good. We would like this supported so it doesn't break. So we'll probably need to insert some kind of interior walls just to support this board. Now at the bottom of the Microbit board there are quite a lot of components present, and unfortunately the version of the Microbit board I found on a site called GrabCAD is the Microbit version 1. You have the Microbit version 2. The footprint itself is not different, but some of the components on the bottom of the Microbit are actually placed differently on your board as compared to the board we have here. So we will need to ensure that the walls I'd like to create do not cover any of the areas that are not similar in size. And Actually, the very edges of the board seems to be free of components in both versions, so let's do a few walls around here supporting the board. So we'll go into the top and say I actually would like a thin wall here and a thin wall here to support the microbit. So once more I will sketch onto the top surface of the bottom and just hit R for a rectangle, and we will place this somewhere along here. Actually, I would like to project some geometry using construction lines. So this and this line would be good to have, because then I know where to place the rectangles. So deselect the construction geometry, hit R for rectangle, and now I can draw a rectangle around this area, and I would like this one to be around 2 millimeters in thickness, should be fine. And just select some nice values for this, and 20 in length, that should do it. So again, I'll hit line and do a construction line from the origin down to the bottom, just in order to have something that I can mirror around. So now I'll just select all 4 sides of the rectangle and mirror them around the center line, so the same rectangle appears over here. So finish, and as I actually have these various components present, when we extrude we can use the existing geometry as a guideline. So I'll hit these 2 rectangles, and instead of choosing distance I'll choose to object, and then hit the bottom of the microbit controller, and then they're extruded right onto that surface. Again, right onto that surface, and again, to allow for any tolerances, I would actually like to adjust the offset just a little bit. So say -0.3, reverse, it should be 0.3 in the offset direction. So now you can see there's a little gap below the microbit board, which is good. So I'll hit OK. So now we have a bottom that holds the center bit in place with these 2 studs on both sides, and we've got 2 walls supporting the microbit itself. So of course next we would like some walls around the microbit. Yeah, so let's construct these. So I'll go into the top, zoom out to see it all, and once more I'll sketch on the top surface of the bottom enclosure, and hit P for project, and I'd like these 4 lines to be included. This one is because we did the cutout for the various pins. Actually, all the way through we'll need to correct this, because there should be a wall, there shouldn't be a hole here. There's really no reason why this rectangle goes all the way to the edge, so I'll correct that in just a moment. So let's do another rectangle. We can actually just hit O for offset, and let's do a wall size of about 1.5. So again, just looking through, seeing whether or not my interior wall touch my design. Doesn't seem to. So we just need to close these 2 in the bottom. So hit L and close the outer one, and L and close the inner one. So now I should have this area and this area to extrude. So hit finish and choose E, select this and this. So now we just need to decide how tall our wall should be. So I of course need to allow some holes to get access to these pins. That should actually be in the top cover. Again, we're doing the bottom right now, so probably a good starting point should be at the top of the Microbit controller. So let's do that. So I will choose to object and just hit the top of the Microbit. So now my walls will actually be this high. Should be fine. Then I can do another insert on top. But we had this whole problem down here. Well, one thing we could do is to extrude in two sides. So that was one side, but then we also extrude down into it here. This will actually mean that we are cutting it, because now we're actually doing an extrusion into an object. But you can override this just selecting join down here. And if I hit OK, then we get a wall around the entire Microbit, which is pretty much ideal for this purpose. I would like some rounded edges, so let's do some fillets on the walls. So F for fillet, hit this one, and the interior, and the interior and exterior, same up here. And finally this corner over here. And then we just hit a nice value. 4mm seems to be good. So I'll just hit OK. And now we actually have the bottom pretty much done. So next up we will create a top that goes over the enclosure and has holes and cutouts for the various LEDs and the push buttons, and again gives access to all these pins so that we can expand with sensors outside the box. We of course need to lock the two boxes, the bottom and the top, into place. There are a great deal of ways in which to do this. One would be to create a snap fit, and I think that might actually be a good choice here. So basically let's do some studs on the top one that goes into a slot here, here and here. So that means it'll lock into place and, well, somewhat into place. Another way to go, which I often employ when I do manual things, is to use screws and bolts in order to hold it into place. And in this case, I'll just find some areas. This one, of course, would be ideal because that's actually a hole, so we could do a bolt from top to bottom. But since you might not have access to M3 bolts, let's just do a soft enclosure where it snaps into place. So I'll do a cutout on this side. Just rotate it a bit so we can notice it. So in this case, I'll just draw a rectangle and say this should be here, and let's create one about 2.5mm in height and 5mm in length. And I'll just hit D and position it 9mm from this edge and 1.5mm below the top edge. So I'll hit finish and do an extrusion of this little part by, let's say, -0.75. So this just creates a little gap in the wall. So if we do a sort of tap here with a little bit of extrusion down here and create the right amount of thickness of the tap, it'll just flex and snap into place down here. And again, trial and error. If we make it too tight, it'll break off, and if we make it too loose, the lid will come off. So that's a thing. I'll actually print a few just to find out what I'd like as a force. So this one I would like to mirror. So create a mirror, selecting the feature, we just extrude it, and a mirror plane, and again this one should be centered, so there is a mirror plane hiding somewhere in the center, and it's not that easily apparent where this one would be. But if we go into this one, we actually gain access to all the different things. I still can't see them, so I'll just hide these. Okay, there we go. This is the plane I wanted to mirror about. Hit OK. So if we look to the other side, you will see the same cutout here. Unfortunately, of course, I can't actually do the same here. So here I'll need to select this one. And I would like a rectangle that corresponds to the other ones. I'll just hit P and select construction and just take these two lines and project them onto my geometry, because then they're actually present here. If I likewise project this and this line, then I have access to both sides. So now I can just hit L, and I'm still in the construction mode. And if I select that point and go to that point, and likewise at the bottom, then I know my rectangle has to be located top and bottom on this one. So hit escape to finish the construction lines, deselect the construction, hit R for a rectangle, and now I can just draw it from top to bottom. Again, I can do the trick where I just hit L and do a construction line from the origin to the center of the box and make this one vertical. Finally, we'll just need to set the size, dimension from side to side, and this one was 5 millimeters in length, and hit E for extrude. Take this one and do the minus 0.75. So now I've got the locations for the 3 tabs for the top. So of course this one should be printed facing down, so there's nothing here that would prevent me from printing a lid, since everything conforms to gravity. So there's no overhangs, there's no problems there, so that's fine. So we'll just make these two visible again, and we can just go to the top level and try to visualize that. Yeah, everything seems to be present, and we're ready to create the lid that goes over the enclosure. So the lid will need to go above this one, but that's actually also about the place where the bottoms are. So we'll probably just do some cutouts and do some chamfers on the edges, so we get some nice rounded depressions where we can hit the bottoms. And then of course we probably need to do a let's just do cutout for the LEDs. I was thinking about doing a depression to gain more access. We'll see if we can do that in a moment. But first off, of course, we need to create the lid. So right click on the top level, hit new component, and we'll name this one lid. And in this case, I'll draw on the top surface of the bottom enclosure. And that's simply because then I can project these onto the sketch. So I can do the outer surface that will conform perfectly. And on the inner side, of course, once more, I will need an offset. So first off, hit P and just select the surface and hit OK. And now I've got this geometry easily available. Next, hit O for offset and select the inner one. And again, I'll do a 0.3, I think, offset here. So notice that the inner surface will just be moved a little bit inwards. So I'll hit OK. And finally, I can prepare that I would actually like the... okay, this one actually... No, I will not do that yet. Okay, that's it. Hit finish and choose the E for extrude. I'll first off just take the top and move it up to this part, the receptacle for the microbit, and I'll just hit OK. So now we've got the initial part of the lid. Next off, of course, we'll need to close it. So I'll do another extrusion on the top of my my lid. Hit P for project and select the surface and hit OK. Finish the sketch, choose E for extrusion and select both the enclosures, and let's do the 1.5 thickness that we also created earlier. Actually, well, I could do some cutouts for the various buttons, but I could also do this beforehand. So I think I'll actually change my mind and just edit the sketch I just created in order to do the cutouts for the buttons and the LEDs present in this area. And of course also all the pins down here. So first off, let's do the buttons. So we'll just zoom in, and once more we can hit P for project. I'll do the construction geometry here and hit OK. The reason I do the construction geometry is that, again, I want an offset surrounding the button. Actually, this one I think might be easier if I create a rectangle. You might notice that the bottoms have an irregular appearance, so what I just selected was not the outer surface. So we'll do the rectangle thing. So just hit the top, and still a good idea to project it because I have access to the center of the button. Hit R and do the center rectangle using that point, and then I'll just move it somewhat out. Hit D for distance, and the distance between these two should be 0.3 like before. And the distance from this to this point should also be 0.3, so I just hit the same dimension. So now I have a 0.3 distance from the bottom and outwards. I could do the same on the opposite side, but once more it's symmetric, so I'll just create an L construction line going through the entire center of my lid, and then I can create a mirror of the outer surfaces or lines of my rectangle using the center line as an offset. And wow, would you notice that it's not symmetric? So there you go. Bad idea. I'll just hit Control C. So we actually need to project this one and do it all over again. So hit P, hit construction, use the surface, and again do the rectangle, and deselect the construction. Should be a center rectangle. And here I can use the equal constraint. So this side should be equal to that side. This side should be equal to this side. So that's better. We've selected the button. And next off, we'll do the cutout for the LEDs. So, initially, we would like a rectangle. Yeah, let's just do a rectangle all the way around the LEDs. I'll just do the dimension tool. Let's see if we can gain access to anything down here. It's not always possible. Yep. There was a little one lighting up just a little bit ago. Well, I can't actually. So I'll just need to hit P and do this point, for instance. And likewise, I'd like this point and that point, so that I may adjust stuff accordingly. So now I can do the distance from the point here to the surface, saying in this case I want a little bit further distance so the light may appear. So I'll just do a millimeter. And likewise over here. And finally the same at the top. And again, I always do it with a single distance, because if I change my mind and say, well, this should actually just be 0.75, it'll update all around. So I like that option. Of course, this is not necessarily the best layout. I actually would like some round edges up here, so let's do a fillet on this one and this one. And this could be pretty large, so let's just get a 7.5 millimeter fillet. Yep, that's good. So now we have the headers down here. So once more, we will create a rectangle conforming to the one at the bottom, so hit P. And I actually can't gain access to them because, again, we have geometry in the way. But again, if I click and hold, then the edge will be available. And I'll just do that edge singly. So hit OK. And this should not have been a construction, so I'll just make it a full line and hit L and do a cutout. All around. Just need to ensure, I don't think this was vertical, so I'll just select it and make it vertical. So this actually looks pretty good going off the bat. In this case, I won't do these headers down here because I don't know whether or not you'll use them or not, but let's assume that you won't actually use them. So now, if I hit finish, I should be able to do the extrusion of the top part, but leave a lot of holes for the buttons, the LEDs, and the headers. Likewise, select the out one, and then just do the extrusion of 1.5 and hit OK. So I'm pretty happy with this one. It actually looks pretty good. Of course, there's a bit of a gap down to the board, so if you wanted, you could of course, go to the bottom of the lid and draw them down. I'll just leave them as is. The only thing I'm a little bit maybe not that happy about is whether or not we can actually hit these buttons. Of course, it's also a feature, it's a protection, so we don't accidentally push them. But let's create a little bit more user-friendly design if we want ease of use. So if I hit modify and chamfer, this allows me to make sort of the same as fillets, but these are angled cutouts. So if I do this to a distance of 1.5, then it'll go through all the enclosure, but again the bottom actually sticks up a bit, so I think the one was actually better. So 1 millimeter seems to be good. Then I'm going down to the surface of the bottom. So I'll just do the same over here. Hit plus, and these 4 edges, and 1 millimeter also over there. So if I hit OK, then I have a chamfered finish to the buttons. The header part should probably have a box going around it, both in order to stabilize whatever you insert, but also actually to make sure that the bottom sensor bit part stays in place. As of now, it's just laying flat on the surface, so it can actually move up and down if you take your entire enclosure and shake it. So let's just do an extrusion of the inner part here, going down to the surface of the sensor bit board. Of course, we need to be careful in this area because there's not that much space between the headers. But let's see what we can do. So I'll just deselect the bottom and hit the inner part of the lid and create a sketch. So first off, we'll need to project the hole itself. So let's just hide the sensor bit part. So I'd like the, well, of course they are easy, sorry, I don't need to project them, I'm actually drawing on that surface, so they are present. So let's again just hide the sensor bit and do an offset of this rectangle outwards. So -1, let's do that up front. And if I show the sensor bit again, -1 seems to be somewhat okay. They go onto the parts here, but that's pretty okay. I think I could actually do 1.5 maybe. That's a little bit much. Let's say -1.25. So we leave a little bit of distance to the headers. So hit OK. Next up, I will extrude this part, and I'll extrude it down to the studs we created on the bottom. So I'll just make that one visible again and say I want it down to here. So 2 objects, forgot about that one, sorry, and go on to this face. Maybe with a little bit of offset, so 0.3 offset, and hit OK. So now the rows are accessible, but I've got a nice chorus down. Well, now that we're doing that, let's also do that in the LEDs, just to make sure that the microbit board itself is also actually supported and won't rattle when we shake the enclosure. So let's do that one. So again, I'll deselect the bottom, and first off we'll just deselect the microbit, hit this surface, draw on it, and do an offset of this one, and let's do the -1.25, same as before, and let's show the microbit again. should be good. And then we'll just do the extrusion. So hit finish sketch. Oh, did I actually click OK? I think I got it, yeah. So hit the extrusion, and we'll need the profile, so just select that one, choose to object, and we'll do this one to the top of the Microbit board with again a little offset. So just make sure that we have the offset I'd like. Yeah, 0.3 seems good. So now we've got the cutout, we've got the LEDs, but they are nicely enclosed. Good. So we're nearing the final thing, but of course you need to power the Microbit. So there's a USB micro plug at the end. There's also a white plug at the very end, and I don't know whether or not you'll need the sound, but there's a jack in the sensor bit, which we'll also like access to. So we just need a few holes in the sides of the bottom enclosure. So let's do that. So I'll switch to the bottom one, just hide the lid, and I'd like to do the cutouts for the white plug and the USB micro. So this one and this one at this edge. So hit this one, hit sketch, and first I'll just hide the bottom, and I think I'll hide the sensor bit as well, because then it's easier to see where the features are. So here we've got the USB-C, sorry, not USB-C, micro USB. So just hit an R, and let's just do a rough rectangle around it. Next off, do the white plug, and again a rough rectangle around this one. I won't dimension these ones, shouldn't be necessary, but of course you're free to do so if you wish. So the warning that came was just because I have hidden the geometry just to draw these two aligned. Maybe I'd just like these two to be in line, so let's do the collinear constraint. This just ensures that these two are lying on a line. So just, yeah, for aesthetics. So hit E for extrude, and I'll cut these two out right to the inner surface of the bottom. So this one. So moving around, and if we go to the top level, you can see that we've got access to the micro USB and the right plug over here. So finally, of course, there was the jack plug on the sensor bit. So let's just hide the Microbit and get the sensor bit. Draw a cutout on this side and just hide the bottom and say this is actually the one we wanted. So let's just do a projection first off of the hole itself, just to get access to the center. Then do the C for circle and make a large enough hole. So 5.3 should do it. And it will show the bottom again. Hit finish, choose E for extrude, take this one and extrude it to the inner surface. And we have access to the jack, if indeed you need it. I don't know whether or not you do, but now it's available. There's also a micro USB plug on the sensor bit. I've not made a cut in the box to that one because again we've got the micro USB up here, so hopefully that should do it. So finally we need the various latches that snap into place so the tops actually stay in place. So let's just hide all the sensor bit parts, because now it's just basically box to box, lid to bottom. So we'll do the lid. In this part, of course, it gets a little difficult to view what's in there because, well, it's enclosed. But if we do the inspect and do the section analysis, hit the side, then I can actually just gain access to this part here. So now I can actually see the cutouts. So hit OK, which makes it a little bit easier to go into the drawing and get this one. Maybe this is not the orientation that would actually be helpful here. So let's just do another section from the top and just remove the very top so we can see inside the case. So let's do that one. You might notice now I have actually two sections because they're just present here, but you can only visit one at a time, but you can just switch between them up here. So this one's good. So we would like a tab to be present from the very top of the lid, going down to this area here with a small protrusion. It should have a triangular appearance so that it'll automatically, once it hit this surface, be pushed inwards. That also means that normally I would probably create this one to be right located on this side, but actually I want a little bit of distance from the top to the bottom so it can actually sort of bend and snap into place. So actually, let's just hide the analysis, hide the bottom, and rotate around. So what I'm actually convincing myself is that I would like them to be drawn on the top surface and don't contact the sides, just to ensure that the tabs are actually flexible. So let's sketch on the top. Again, now we need to find out where were these cutouts in the bottom. So I'll just hide the lid, and then we'll just project using the construction geometry this line. Hit OK. Now we can hide the bottom, show the lid, rotate around. So this is the area we're trying to hit. Okay. Let's zoom in. So again, I won't create a rectangle going right up to the wall because then I don't have that long lever. So I'll do the R, and first off just draw a rectangle, shouldn't be a construction, by freehand. So first off, let's ensure that these are aligned. So if I hit the horizontal and say this should be horizontal to, sorry, let's do that again. So this one should be located horizontally and this one should be located horizontally. So now again we are just ensuring that they are placed correctly. Next up, hit D for distance and say what should be the distance between these two. Let's do a 0.3. And finally, how thick should the tab be? Again, the thicker you create it, the less flexible it'll be. So just try creating a 1. Hit finish, and I'll do an extrusion of this one. And this one should of course go all the way. Just zoom out a bit. Here we go. To the bottom of the cutout, almost. Again, respecting the tolerance. So we'll select this surface, and I'll be a little bit more generous here. Say the offset should be, let's say, 0.5, so it won't go all the way to the bottom. Likewise, I made an error going right up to the sides here, but it doesn't matter because we actually need to create a geometry on top of the tab that snaps into place over here. So that's actually okay. We just need to be certain that we do it correctly when we draw the triangle next. So hit OK. So let's hit this surface here and do a sketch. Now I would actually like to see the section here. So now it just makes it easier to draw the right triangle. So hit an L and go from this corner somewhat into this one again. If I do too much, then it'll snap off. Let's just do this part here and do a distance from this point to that line, using 0.25 in this case, and a distance from here to here of, let's say, 0.3. Should be okay. I think I'll do this one just a little bit at 0.4. So now when I push this, it should bend. So this one gets bent into the enclosure, but once it hits this cutout, it'll snap out and lock it into place. Again, trial and error how tight the tolerances should be, but I'll do finish. You might notice that I actually drew this one right to the very edge, which I said was not that good, but fortunately something can be done. So let's just hide the analysis, hide the bottom. So what I'm talking about is this one was going right to the edges of the cutouts. But if I hit E and choose this little part, normally I'd do this extrusion and do the to object. We can actually do the to object because we need that. So going right up there. But again, now it is actually a little bit too thick and it'll maybe have some problems. So one way to fix this is to say that yes, I wanted to begin at the profile plane, but I can actually also choose an offset. So let's just make this 0.3, reverse direction, so minus 0.3. Likewise down here, where it ends, I will need an offset. Let's try a 0.3, again, negative 0.3. So now it doesn't actually contact the edges of the cutouts. So if I hit OK, and I'll choose the bottom, then there's a little bit of distance between this and this. We can just verify, inspect, and notice that indeed there are 0.3 millimeters between these two surfaces. So that should be okay. Next up, of course, we need to rotate this to mirror this onto the other side. So I will select the create mirror, and it's set to features. That's good. So we need the initial and the triangle, and the mirror plane should be this plane. Hit OK. So now we've got the two snaps on both sides. Finally, of course, we need the snap down here, which unfortunately again can't be mirrored or anything the likes, so we'll just need to create it all over again. So the very last part of the case, show the lid, go to the top, and we need to create it here in the center. So I'll just draw it down here. So we need a rectangle, and I believe it was 1 millimeters in thickness. And let's not do the same error. So I hit 5 before. So 5 minus 2 by 0.3 would be 4.4. Again, do the trick where I just hit L and a construction line from the origin to the center of this one and make sure this one's vertical. Then I know it's located in the area, and then I hit D for distance and say there should be 0.3 millimeters between these two. Finish. And do the extrusion of this one to the bottom of this one. There we go. I did a 0.3 offset last time. It's not really necessary because again we do a triangle just a little bit, but just to be consistent I'll do it again. So now we can actually disregard that offset because now there are 0.3 millimeters between the sides. So I'll just hit the side, sketch, deselect the bottom, get the lid. Sorry. There we go. And did I have a section that was appropriate for this one? Well, I actually don't need the section, sorry. So, again hit L for a line. Going from here, upwards and inwards, and then again we need to select some distances. So let's just hide the lid, get access to this one. There's something wrong here because this one didn't snap onto the lid. We'll fix that in just a moment. So first off, let's do a distance between the top part and this one. Oh, not the right distance. Shouldn't be curved in that regard. So I'll just, sorry, it was too tall already. That's it. So distance here to here. Damn it. It won't allow me to do the right distance. Sorry, I'll just be sure that I'm actually viewing it correctly. It seems to be okay. Okay, let's try it again. Distance here to there we go. So 0.3, and this one I think was 0.4. Yep. Hit finish, hit extrude, and take this one to the other side. And it joins so. Okay. Seems good, but again there was a problem with the body because I've hidden the lid and this one's still present, so it's not attached to the lid. So let's just see what happened. So the extrusion can be a little bit difficult to identify, but if you hit a geometry, then you can actually see where it comes from. So this one was actually the extrusion. So if I edit the feature, it's set to a new body. It should have been set to join. Okay, then this one is a lost projection. So I'll redefine the sketch plane to be there. I should do it. Yeah. And next up we'll just edit this feature, going from there on to this side. So yeah, no warnings, everything's good, and hopefully if I hide the lid, yeah, the tab disappears. So now it's actually present in the right direction. So I hope this should be a suitable enclosure. you'll need to print that out by yourself in order to see whether or not this actually lives up to the expectations, and you can always, of course, change it according to need, but this should be a nice enclosure, and of course you can do the text and whatever you like. You could also do the chamfers on top, and if you need or do not need the white plug, well, just don't cut it out. This is just to give you inspiration for how to do an enclosure. It makes it a little bit more professional if you have a demo board or something like that, and you need to show it to somebody that you can actually show a nice enclosed thing instead of just a bunch of wires going hither and here and there and everywhere. Of course, if you wanted specific sensors, you could build the box a little bit bigger to hide them inside and do all that. But I will leave that one to you. You're of course welcome to contact me if you'd like some more help with your individual designs, or whatever you like. But again, these should be 3D printable and make a suitable enclosure. So that's it. Thanks for now.